Welcome to A-Star Science, part of our GCSE Must Know Chemistry series. Today we're going to talk about the chemistry of the atmosphere. And let's first start looking at our modern day atmosphere and seeing what the components are. So in the modern day atmosphere, meaning the atmosphere that we have around us today, no matter where you go in the earth, the composition of gases tends to be the same. We have around 78% nitrogen gas, 21% oxygen, and then 1% trace gases, meaning they're in very small amounts. And that includes things like argon, water vapor, and of course, carbon dioxide. So this is the modern day atmosphere that you need to know for your GCSEs. But the modern day atmosphere has not always been that way, or the atmosphere hasn't always resembled that of the modern day atmosphere. And we're going to use these images just to tell the story of how the atmosphere, the chemistry of the atmosphere, has changed over time. Remember, this process has taken billions and billions of years. And so scientists are not sure exactly of what the early atmosphere was like because it was so long ago and there was no one there to record it. But they can, based off of the evidence that they found, understand what the early atmosphere was like. So let's start with the image number 1. This represents the earliest of atmosphere. And the atmosphere at that time was quite hot. And scientists believe that it was primarily made up of gases like carbon dioxide, ammonia, and methane, or methane gas, as well as there would have been lots of water, but in the form of a vapor. So I'm going to call that a gas in form of steam or vapor in the atmosphere. So those were the main gases that would have occurred in the first stage of the formation of our early atmosphere. Now, over time, that atmosphere would cool down. And so that's what we see in number 2. And so that water vapor, which write as a gas, would become liquid water. In fact, scientists believe that it would form shallow seas. And this is going to be important because the carbon dioxide that was present in the early atmosphere would then dissolve into these shallow seas. And so we can see the carbon dioxide starts to decrease from the large amounts that was in the early atmosphere to a lesser amount, but there's still lots of carbon dioxide in that particular early atmosphere. They also believe that the ammonia would start to break down due to the sun's action, sunlight. And that would break down particularly into nitrogen gas, which is quite unreactive. So we can already see that the atmosphere's chemistry is changing. Now, what's happening in stage 3? Well, scientists believe that in the shallow seas that we talked about before, that formed from when the atmosphere cooled down, that eventually life started to form. The earliest life form, they believe, were cyanobacteria and other types of bacteria. Now, cyano means blue-green. And so these blue-green bacteria were able to photosynthesize. And that meant that the carbon dioxide, again, which was already decreasing from the oceans, would also be taken up through photosynthesis. Now, a byproduct of this was the formation of oxygen. And so we started to get oxygen, the first oxygen being formed as a result of these early cyanobacteria. There were no large plants and trees at this time. The only thing doing photosynthesis were the cyanobacteria, but that was enough to make the carbon dioxide go down and the oxygen levels start to go up. So let's look at this fourth stage here. And what scientists believe that carbon dioxide was also stored or taken up by marine shellfish. Now, we're not talking about large shellfish like what we see today. We're talking about very small, microscopic shellfish that would eventually form. And they would take up this carbon dioxide and use it to form parts of their shells. And this would also then, eventually, when they die, form sedimentary rock, like limestone. So we can see the carbon and the carbon dioxide is becoming stored in things like sedimentary rock, as well as in things like fossil fuels as well, which was formed from when these microscopic organisms, many of them would die. So we see the carbon dioxide is continuing to go down, and oxygen levels is starting to go up. Now, when the large plants would start to form, like we see in stage 5, we call these vascular plants because they have veins and different structures to carry the fluids within them. They're not like cyanobacteria and algae. These were vascular plants. These large plants will start to produce a lot more oxygen. But of course, they need carbon dioxide to do this through that same process of photosynthesis. So the carbon dioxide will go down, the oxygen levels would start to go up, and that would eventually form the atmosphere that we have today, which we can remind ourselves is 78% nitrogen gas, 21% oxygen gas, which was formed from that photosynthesis of plants, and it still is formed from the photosynthesis of plants, and less than 1% trace gases like argon and carbon dioxide. Now, our atmosphere is quite stable, but it is still subject to change now because of the actions of man. As we know, humans are burning lots of fossil fuels, and fossil fuels contain lots of carbon. And so when they are burned, that releases carbon dioxide. So the carbon dioxide levels are starting to go up, and scientists believe that that is causing changes in our atmosphere, which we call global warming, which can be responsible for a phenomenon we call climate change. And we'll learn more about this in other videos and ways that we can prevent this. So this is the chemistry of the atmosphere and how the atmosphere has changed over time. Scientists believe that our atmosphere was actually quite like other atmospheres present in our solar systems, like Mars and Venus. But our atmosphere over the time has changed from that, primarily due to the action of green plants. Please make sure you like and subscribe. Leave a comment if you'd like me to do any specific videos on any of your topics from your GCSE.